In this video, we're going to be talking about intervals of continuity. Okay, so basically, this isn't asking if you're continuous at a specific spot. It's saying, give me all the numbers you're continuous at. All right, so just a couple of rules. One is that polynomials, if you're just looking at polynomials, they are continuous everywhere. Okay. E to the x, also continuous everywhere. Sine and cosine, also continuous everywhere. Okay, let's talk about some of the funkier stuff. The natural log. The natural log is only continuous on 0 to infinity. And you want a parenthesis on 0. That's because the natural x function looks like that guy. So it is one continuous curve, but I can't hit 0 or go to the negative side. Okay. Square root of x. That guy is continuous on 0 to infinity with a bracket. And the reason why that has a bracket is because it actually touches 0 and then goes to the side. All right. And cube root x. This is continuous actually everywhere. It looks like this guy. Okay. These facts can be helpful as you are looking at a problem to try and decide where a function is continuous or not. Okay. And of course, you can always take your functions and plug them into Desmos and graph it and see what you get out. Okay. So let's talk about kind of some stranger creatures. Okay. So let's say, for example, if I was given the function e to the x over x minus 3. And I was asked to tell intervals of continuity. Where is this continuous? Okay. Well, let's talk about some things. Number one, e to the x is continuous everywhere. So there's not a problem on the top. The top's good to go. Okay. The bottom, though, anytime I have a denominator, I always have to be careful about equaling 0. And that's going to happen at 3. So I'm saying that x can't be 3, but otherwise we should be good to go. So without even graphing and knowing what this thing looks like, the actual, sketch of it, I can at least say right off the bat that this is going to be continuous everywhere but 3. Now the way that we write that in interval notation is to say negative infinity to 3 with parentheses union 3 to infinity. Some students try to write that. Nope. Interval notation, people. You got to write it that way. Okay. What if I flip this function? What if I was asked to do f of x equals x minus 3 over e to the x? Okay. Interesting. So if I flipped it and I was asked about this, well, this is continuous everywhere. E to the x is continuous everywhere, but more importantly, does e to the x ever equal 0? Try and solve it. What's going to happen is that e to the x never equals 0. So this beautiful, glorious function I just made up is continuous everywhere. Okay. Again, if you're not as quick to be able to come up with what I'm doing, you can always graph it in Desmos, see what kind of picture you're getting, and then backtrack to the equation and see if you can figure out what the heck they did. All right? So for this section, just keep at it, keep persisting. You're going to have hybrids of lots of interesting functions, but this list will help you kind of get started as to the facts about functions in general.